So I'm going to talk you through the procedure here so that you can see how we're actually going to figure out how much energy is in these different types of foods. Now, on your data table, you see 6 different types of foods. We chose these because they're all easy to start on fire and measure. However, we've had really terrible luck with the kidney beans this year. So we're actually not going to do anything with kidney beans. You can just go ahead and cross that off on your data table. We're not going to do anything with kidney beans. So I'm going to show you how we can determine the relative amount of food in a marshmallow. We'll go through this part step by step. I'll actually write the values on the board for the marshmallow, and then I'm going to show you videos of data collection for the peanut, almond, walnut, and cheese puff, and then you can actually just go ahead and plug that in the data table on your own. So here's the basic idea. What we're going to do here is we are going to put food on a little food holder underneath the can. The can will have water in it. We're going to light the food on fire, and we're going to measure how much the temperature of the water in the can heats up. And we're going to assume that the more the water increases in temperature, the more energy was released by the food and the more energy was initially stored in that food. So right now, all of the energy that we have is stored in the chemical bonds within the food, and as it burns, it's releasing that energy in the form of thermal energy or heat, and we can pick up some of that by the can. Okay, so taking a look at the data table, the first thing that we need to figure out is the mass of the empty can. So we're going to take the can off of the ring holder, put it on the scale here. I also have a paper clip. We're going to put that in there. And the mass of the empty can is 16.4 grams. So you can write that in your data table, 16.4 grams. Now it says mass of the empty can plus water. So we're actually going to add 100 milliliters of water just from the sink, room temperature. And we're going to put that into our can as well. And a mass or 100 milliliters of water should have a mass really close to 100 grams. So let's see how I did. 115.1. So not exactly 100 milliliters, but pretty close. All right, and we're going to hang this on the ring holder. The ring. Okay. Next, we need to figure out the minimum temperature of the water. So we're actually going to put this temperature probe into the can. Don't want it touching the bottom of the can, but just off the bottom and hitting just the water there. And it looks like our minimum temperature of the water is 22.8 degrees Celsius. So that's pretty close to about 70 degrees Fahrenheit. All right, the last thing we need to do before we light this food on fire is figure out the initial mass of the food and the food holder. The reason we factor in the food holder is in case some of the food falls off while it's burning, we can also find the mass of those crumbs afterwards. So 13.9 is our initial mass. Okay. Now, I want this to be a bit closer. There we go. We want that to be closer to the food so we can pick up a lot of that heat. All right. Still in the water. There we go, 22.8. Okay. All right, let's burn this food. Any of you like your marshmallows burnt, like my sister? I'm more of a golden brown marshmallow kind of person. But if you like your marshmallows burnt, then you'll appreciate this. So again, the energy that was stored as chemical energy in the marshmallow is being released as thermal energy, and we're going to try and measure some of that, whatever we can capture with the can. And we're almost there. Okay, so the maximum temperature I think I saw was 34 degrees Celsius. And the final mass, 13.1 grams. So what happened to the mass? Actually, as the marshmallow was burning, it lost mass, right? When we burn something, some of the atoms that were stored in that marshmallow are now released into the air. Some may end up as soot on the can, but we lost some mass. All right, so I'm going to show you now the peanut, almond, walnut, and cheese puff. I'm going to zoom in a little bit closer so you can just see these numbers, and you can go ahead and plug those into your table as you watch. All right, so just table 1. We're going to come back and do table 2 after we've collected all of our table 1 data. All right, next we're going to take a look at the peanut. So mass of the empty can. We dumped out the water from the previous trial. The mass of the empty can is 14.9 grams. Now we're going to add 100 milliliters of water to the can. And we're up to 113.8 grams. Okay, let's get this set up here. Our thermometer. Planters Peanuts, the unofficial sponsor of this segment. There we go. And looks like our minimum water temperature is 22.9 degrees Celsius. And initial mass of the food and food holder, 8.5 grams. 8.5 grams. All right, let's burn a peanut. Any of you have a peanut allergy? Hopefully it cannot affect you through a computer screen. I think you'll be all right. All right, there it goes. Take a look at the temperature. See what the highest temperature. See 39.2. And the final mass of the food in the food holder, 8.5 0.1. All right, next we're going to take a look at the almond, one of my favorite healthy snacks. Mass of the empty can, 21.7. It got heavier somehow. Okay, adding 100 milliliters of water. We're up to 120.5. And while the almond is burning, we're going to have a conversation about constant variables. So if you haven't filled out the constant variables yet, you should be feeling confident about that here soon. Okay, we're all set. Temperature probe is in the water. Let's center this a little bit more here. There we go. Our initial temperature is 22.9. Initial mass of the almond in the food holder, 9.1. And let's burn an almond. This one takes a little bit longer usually to get going, but once it starts, it's usually a pretty good burn. Ooh, close. Okay, so. All right, while we sit here and watch the almond burn, let's have a quick conversation about constant variables here. So remember, constants are all of the variables in your experiment that are not the independent or dependent variable. So to be a legitimate controlled scientific experiment, we want to change the independent variable, and that in this case, that's the type of food. We're changing the type of food. We're measuring the energy content of the food. We want to keep everything else from trial to trial exactly the same. So what are we keeping exactly the same? What are our constants? Well, we're putting the same amount of water, 100 milliliters, into the can each time, or close to it. That water is starting at about the same temperature, right around 22, 23 degrees Celsius. We are, if you've noticed, trying to keep the food about the same distance from the bottom of the can, right? We're not having one food down here and another food touching the can. We're trying to keep it just about a half an inch under the can. Those would be, I would say, three really important constants. We're using the same can, right? Some cans might be thicker or thinner and conduct heat a little bit differently. So we're using the same can and generally the same equipment from trial to trial as well. So those would be some of our constants for this experiment. Oh no, we might lose it. Still there. All right, it's about at the end of its burn. So let's keep an eye on the temperature, see what the maximum temperature is. There it goes. I see 53.5, 53.6 degrees Celsius. And the final mass, 8.2 grams. And here we have the walnuts. Walnuts are a good healthy snack as well, high in omega-3 fats, I believe. All right, empty can, 15.2. Let's add some water to that. $14.2, 114.2. Minimum water temp, 23. Oh, initial mass of the food in the food holder. Almost forgot. 9.7. Okay, again, keeping the distance from the food to the can as close as possible. As constant as possible. And this is my favorite one to burn. You'll see why. So while this is burning, let's just take a quick look at what's even in a walnut. And take a look at the nutrition label here. So, see it burning in the background. So when you look at walnuts, so it looks like one serving of walnuts has about 28 grams. If you look at the very top, there are 28 grams. And in 28 grams of walnut, you're going to be eating mostly fat. 18 of those 28 grams are coming from fat. You can see that right there. Okay, most of those are unsaturated fats, which you're going to learn are the healthier kinds of fats. So walnuts really are a good healthy snack. Obviously, everything in moderation, but those unsaturated fats are all right. 4 grams of carbohydrates, so just a really small amount of carbohydrates and a smaller amount of proteins as well. So when you're looking at a walnut, mostly fat, some protein, some carbs. And wow, look at there, we're up to 57 degrees. Usually in class, we have the students blow out something if it goes above 60 degrees Celsius, just because we don't want to have the can getting dangerously hot, but we'll let it go. See what happens. And looks like it's getting close to the end here for the walnut. And there it goes. Looks like 71.9. And final mass, 8.2. And in this last bit, we're going to take a look at some Planters, cheese balls, cheese puffs. All right, here we go. Mass of empty can, 18.1. Adding 100 milliliters of water. And we see that mass go up to 117.3. 117.3. And our starting water temperature, 23.1. Oh, initial mass of food and food holder, 8.5 grams. Here we go. All right, maximum temperature, it did get up to 29.1 degrees Celsius there. And final mass, 8.1. All right, and that does it for our data collection. Next, we're going to talk a little bit about how to complete Table 2 and actually calculate energy per gram.